Alright, so here we're going to launch a satellite remotely operated that will monitor Kerbin's climate. So let's begin. We'll launch off at the KSC here, where conditions are fairly calm, moderate cloud cover, decent relative humidity, temperatures around 300 Kelvin, around 82 Celsius, or 82 Fahrenheit, sorry, with light winds out of the north-northeast coming onshore. So let's launch. So these solid rocket boosters ignite. This is the first stage of a rocket. We have a second stage which will ignite next, and then a fairing which will deploy as we rise. So as we climb, you'll notice the temperature rapidly dropping as we go through the troposphere. Changes in humidity and visibility occur as we go through layers, and the pressure declines as well rapidly, just as temperature does. So now our second stage is burned out, our first stage is burned out, and our second stage will ignite. So there we go. And we're going to continue to climb. We're only at around 8 kilometers. We've already passed through 500 hectopascals, though, so we're well above half the atmosphere by mass, as you can see here. Now climbing through 200 hectopascals. Winds have died down at this height and are now quite variable, as you can see. We're quite a ways away from exiting the troposphere because in the tropics, the tropical troposphere, tropopause, is quite high, on the order of 20 kilometers or so. However, we have broken the sound barrier, and now we'll begin our gravity turn towards the north-northwest. We're going to add a westerly component to our trajectory here because we're aiming for a polar orbit. And as we head towards the pole, the planet's going to rotate beneath us, and so the westward component of our trajectory will count for this rotation so that we end up in a mostly polar orbit by the time we get to space. So now we're at 30 kilometers, and you can see the temperature is actually increasing with height. We're in the stratosphere here. Humidity is essentially nil, and cloud cover is non-existent because we are now above all the clouds within the troposphere. And you can see here that our prograde marker, the marker that indicates the direction that our rocket's traveling in, now lines up with north on our nav ball. And as we continue to climb, you'll see that winds are largely have an easterly component now. Winds are very light in the tropical stratosphere. There is some rising motion actually in this part of the stratosphere. Once we get past about 5 kilometers, or sorry, 60 kilometers or so, we'll begin to enter the mesosphere. As you can see, temperatures now declining, pressure is minimal, and at 70 kilometers we'll enter space, as you can see here. So we're going to stop our burn there so that our apoapsis is around 250 kilometers above the planet, and we can now look at our suborbital trajectory. So when we get to apoapsis, what we'll do is we will initiate a maneuver. We're going to burn for a certain amount of time until we have an orbit around the planet as such, with an apoapsis and periapsis somewhere around 200 or so kilometers above the planet. So this little node here indicates when we're going to time our burn, so we'll speed up a bit so that we can then get to our maneuver node. Now, Kerbal Weather Project, when you're in space, has a few options here that will show once we get into orbit. It will show you a ground track. So here we are now. We're at a higher latitude, heading northward, obviously over grasslands. So as we approach this node, it's going to take 38 seconds for us to burn through our fuel. So we're going to burn at about halfway through the time there. So there we go. So now what we're doing is we're kind of injecting in the orbit. So we're speeding up so that our periapsis is no longer within the planet, that it's in space. So we ran out of fuel for the second stage, so we'll decouple. We're in space now, so we can deploy our protective shell or our fairing. And now we'll ignite our third stage. So there we go. So this is our satellite here. We'll deploy our solar panels as we accelerate into orbit. There we go. This will keep our satellite charged. We also have these instruments here as well that we can deploy. We'll do that in a moment. So now we've entered orbit here. You can see that our periapsis is around 200 kilometers with an apoapsis around 260 kilometers. So it's not a perfectly circular orbit, somewhat eccentric, but it's okay. So we'll deploy these instruments here using our robotic arms. There we go. And now we are all set. So with Kerbal Weather Project, when you're in space, regardless of what kind of satellite or craft you have, whether it's crewed or uncrewed, you'll be able to essentially see the climatology or the weather at a select launch station while you're in space. So what we see here is along our track, the satellite's moving along, as you can see here, pointing down towards the planet. Kerbal Weather Project shows you the climatological conditions at the location of your satellite along its ground track. So right now we're over the highlands, and you can see temperatures here are decreasing as we head poleward, and we see changes in humidity and wind speed that correspond to those changes. You'll see as well that the amount of precipitable water, which is essentially the liquid quantity of water that you would get if you condensed all the moisture content out of the atmosphere within a given column. And this will vary, especially as we go over water. It will generally decline as we go further north as temperatures decrease and the moisture capacity of the atmosphere declines. So let's speed up a bit, and you'll see here as we head north, we're now over water, and we'll make our way towards the poles. So one of the neat things about this is that there are other mods that allow you to scan the planet and create maps. And I'm hopeful that one day this Kerbal Weather Project will be able to be incorporated into those mods so that you can generate temperature maps and perform science on the climatology of Kerbin. But this is just kind of a start to this project. And since it's just out in an alpha or beta release, this is just the beginning. But here we are over the northern ice shelf, and you can see temperatures here are extremely cold, down to about 212 Kelvin. Which is very, very cold. Wind speeds here are variable, especially near the edge of the ice shelf where you have more polar lows tend to be a bit higher. As we go towards the interior of the polar ice cap, wind speeds sort of die down, and we end up with a bit more stable air mass, as you can see here. Temperatures are very, very cold at the poles here. And as we wrap around the rest of the planet here, you'll see us pass over tundra, grasslands, all sorts of different biomes. And you'll see variations in temperature, humidity, wind speed, and cloud cover as we pass through these different biomes that have different characteristic air masses. So one of the interesting things to note is that even around the equator, there's not that big of a diurnal difference in temperature because of the fact that the planet rotates so quickly. The amount of time that the sun has to heat up the land surface is quite limited, and the same can be said on the dark side of the planet. There's a New Zealand-like continent there, and you'll note that over the water, at relatively mid to high latitudes, temperatures are very, very are generally warmer, and this is because of the fact that the specific heat capacity of water is much greater than on land. Now we're approaching the desert continent here. And we'll see here as we pass through the equator here, temperatures are now in the low 80s in Fahrenheit, around 300 Kelvin. Wind speeds are light. You can see that the precipitation rate here over the tropical oceans is measurable. On average is around 1.5 millimeters per hour if you average over the whole 5-year period, which is what this data is showing. Precipitable water is much higher over the tropics, as you'd expect, and cloud cover is decreasing as we approach the desert. So over the desert, you can see cloud cover is declining. There's less precipitable water. Precipitation rate's a lot slower, as you'd expect. Temperatures are actually a little lower here because now we're well above sea level. And so these are kind of the things that you can do in KSP with Kerbal Weather Project. And then you can run these experiments as well while you're there deploying a scanner. This is not a part of the Kerbal Weather Project mod. This is part of the base game. But eventually it'd be great, I think, to add some functionality, maybe add some parts to the game that would allow you to do, or to emulate real-world science, like, say, TRIM or GPM or other satellites that measure precipitation, or the climatology of, say, temperature and other variables. So thanks for tuning in, and that's all I have. We'll get back to the Space Center next.